Welcome back. The goal for today is to be able to find the distance between 2 points. First off, you need to know what distance in geometry means. The distance between 2 points is the length of the segment with those points as its endpoints. So for example, if we wanted to find the distance between points A and B shown here, we would need to draw a segment from point A to point B and find the length of segment AB to know the distance from A to B. The distance formula on a number line is pretty simple. So in words, the distance between the 2 points is the absolute value of the difference between their coordinates. So if point P has the coordinate x1 and point Q has the coordinate x2, we can find the length of segment PQ by taking the difference in those. Remember, difference means subtraction. So we could either take x2 minus x1, or the other way around also will give you the same answer, x1 minus x2. Since it's absolute value, either way works. Let me show you an example. If we want to use this number line below to find the length of segment BE, first step is to locate the points B and E. Label the first coordinate x1, the second coordinate x2. Now, in order to find the length of BE, I can use this formula, x2 minus x1, which is 2 minus negative 6 with the absolute value. That gives me 2 plus 6, still under absolute value. 2 plus 6 is 8. The absolute value of 8 is 8. Remember, absolute value is asking for the distance from 0. You can also use the other formula, x1 minus x2. So in that case, you would have negative 6 minus 2. That gives you the absolute value of negative 8. Negative 8 is 8 units away from 0. So either way, either formula, you will get the same answer. The length of segment BE is 8 units. Pause the video and try the practice problem below now. Here are the solutions. You can also check your work on these by counting the distance between the 2 points. So for example, from B to E, we have 1, 2, 3, 4, 5, 6, 7, 8 units. And that is what we got. Alright, let me show you how to do distance on a coordinate plane. So this is a little more difficult, but it is extremely important. This formula comes from Pythagorean theorem. So when I'm looking at these 2 points, P and Q on the coordinate plane, I notice first off that point P has the x value x1, point Q has the x value x2. I'm going to put those down on my x coordinate. So I have x2 should be here, x1 should be here. Okay, I'm going to do the same thing with my y coordinates. I want to place them on the y-axis. So I know that point Q has the y value y2, so I'm going to go directly over to my y-axis to plot the value y2. Similarly, for the coordinate for P, the y-coordinate is y1, so I'll plot that on my y-axis as well. Now remember, Pythagorean theorem says that the sum of the squares of the legs equals the square of the hypotenuse. In this case, the hypotenuse has to be, well, the hypotenuse is always C. In this case, it is the length of segment PQ. So I'm going to go ahead and write that down first. However, I don't know A or B yet. However, I can use what I just learned about the distance between 2 points on a number line in order to find an expression to represent the length of A. So if I'm trying to find the length of segment A, it has the endpoints x1 and x2 on the x-axis. So what that means is that A would have to be the absolute value of x2 minus x1. So if I'm finding the distance from x1 to x2 on a number line, that's the formula I just learned. Similarly, for B, the endpoints have the values y2 and y1. So similarly, b would be equal to the absolute value of y2 minus y1. I'm going to write those over here. Sorry about that. Alright, so now what I'm going to do is substitute that in to my Pythagorean theorem. Alright, now I want to solve this for PQ because I'm trying to find the distance from P to Q. So if I want to solve this for PQ, right now I have PQ squared. To get PQ by itself, I have to square root both sides. Remember, when I square root both sides for a length of a segment or a triangle, it can never be negative, so I do not need to include the plus or minus in front of the square root. Okay, so now that I have PQ by itself, this looks great for distance formula. However, using both absolute value and squared is very repetitive. Anything that is squared is automatically going to be positive. So we do not need to take the absolute value of the number first. So we're going to rewrite this as our final answer for distance formula. The distance formula says that distance is equal to the square root of x2 minus x1 squared plus y2 minus y1 squared. Now remember from earlier, we can mix up x2 and x1. It's not going to matter because it's getting squared anyways, so it'll give you the same value. Same here, you could do y1 minus y2 if you want. As long as you keep your x's together and your y's together, you're going to be fine. This is an extremely important formula. Make sure you know it. Alright, because this involves a square root or a radical, that means that distances can be what's called irrational. An irrational number is a number that cannot be written as a fraction. Basically, it just means that it can be a never-ending decimal. Let me show you an example of a problem for finding the distance between 2 points. There are two methods that we can use: distance formula method or Pythagorean theorem method. In both cases, you need to know the formulas. I'll show you distance formula method first. So the first thing you want to do with distance formula method is label your coordinates: x1, y1, x2, y2. So now we can plug them in to our equation. So CD is equal to x2, which is 5, minus x1, which is negative 4, squared, plus y2 is negative 1, minus y1 is negative 6, and don't forget squared. Now all you have to do is follow the order of operations, which says you need to do what is in parentheses first. So we'll simplify this to minus a negative, we can simplify to plus. Same here. We have minus negative 6, we can simplify that to plus 6. So inside of our parentheses we have 5 plus 4, that gives us 9. Negative 1 plus 6 gives us 5. The next step in order of operations are exponents. 9 squared is 81, 5 squared is 25. Next, you'll want to add what's under the square root. That will give you 106. And that square root does not have any perfect squares that go into it, so we do not need to simplify it. If it did simplify, you need to simplify it. You can also find an approximate answer for the length of CD. If you plug it into your calculator, it gives you that CD is about 10.296 units. points. Alright, now let me show you the Pythagorean theorem method. For the Pythagorean theorem method, the first step is to draw a right triangle with your segment as the hypotenuse. Next, you'll want to find the length of each side. So this side is 1, 2, 3, 4, 5 units. This side is 1, 2, 3, 4, 5, 6, 7, 8, 9 units. So my A and B values, remember, are the legs, so they don't matter what order we put them in. I have 5 squared plus 9 squared equals CD squared. Notice here, we have the same exact thing that we had in the distance formula method. 5 squared plus 9 squared, or in other words, 9 squared plus 5 squared. We can simplify this. 5 squared is 25, 9 squared is 81, and that's equal to CD squared. I'm going to put that in parentheses. Alright, add together your like terms. You get 106 equals CD squared. To get CD by itself, we must square root both sides. And we get the same answer that we had using the other method. Again, you could approximate it by plugging in square root of 106 to your calculator. Either method that you choose should get you the correct answer. You don't have to know both methods. You need to know one method and become a pro at it. Pause the video and try the 2 practice problems below. Here's the solution for part A. The length of segment EF is the square root of 269. And your second problem, problem B, practice problem B, is your question of the day. Alright, I'd like you to reflect on this question, please. Explain how you can use Pythagorean theorem to find the distance between 2 points on a coordinate plane.